My project is web-based visualizer for structural representation of C programs. Now let us go with the introduction. Modern compilers and AI code assistants do not understand code as plain text. They convert source code into different internal representations like tokens, AST, CFG, DFG, and CPG. This project visualizes these structures and shows how automata theory concepts are used in a code analysis. Here is the problem statement. Beginners usually see code as plain text and cannot understand how compilers process it. The aim of this project is to develop a web-based tool that takes a C program as input and generates different structural representations such as tokenization, AST, CFG, DFG, CPG. This helps users to understand syntax, execution flow, and data dependencies. And here are some objectives. The objective of this project are perform tokenization, generate abstract syntax tree, that is AST, construct CFG, create a data flow graph, combine them into the code property graph. Demonstrate the connection between automata theory and AI code assistance. Now, let us see what are the definitions of these phases. First, tokenization. It breaks source code into small units called tokens such as keywords, variables, operators, and symbols. It is the first stage of lexical analysis. For example, int a is equals to 5. Here, int is one token and a is one token, is equals to is one token, and 5 is equals to is one token. Next, let us go with the AST. It represents the hierarchical structure of a program and removes unnecessary symbols. Next, let us go with the CFG. It shows the execution path of a program from start to the end. Here you can see the example. Next, DFG. DFG represents how data values move between the variables. Here is the result. Next, CPG. It combines AST, CFG and DFG into one graph and provide a complete view of the program structure. And next is the connection to automata theory. AI assist during tokenization, finite automata such as DFA and NFA recognize keywords, identifiers, operators, and convert source code into the tokens. Automata theory is used in lexical analysis. And here is the example. First is source code, characters, DFA, NFA, and the tokens. Next, let us go to the connection to AI code assistants. AI assistants like ChatGPT, GitHub, Coiplot, and Gemini use these structural representation to understand program logic, control flow, and data dependencies before generating a suggestions. And here are the some applications of this project. This project can be used in AI code assistance, compiler design, bug detection and debugging, software security analysis, program maintenance, execution and learning automata theory. Next, I will show the output when I show the website. Lastly, I would like to conclude this web based visualizer helps users to understand how C programs are analyzed through tokenization, AST, CFG, DFG and CPG. It also shows the relationship between automata theory and AI code assistance, making compiler concepts easier to understand. Here is the home page. Now I will demonstrate the working of my web based visualizer for structural representation of C programs. The user enters a C program in a code editor and clicks on the analysis code. Here we got output summary. After analysis, the system the system displays a summary containing the number of tokens, variables detected and functions detected. In this program, we have 14 tokens and the variables detected is 1, functions detected is 1. Next, let us go to the tokenization. Here, lexical analyzer breaks the source code into meaningful tokens such as keywords, identifiers, operators and symbols. Tokenization is the first stage of compilation. Next, let us go with the AST, which represents the hierarchical structure of the program. It removes unnecessary symbols and shows the relationship between the statements. Here we can see the variables, declaration and return statement organized in a tree structure. Next, CFG, control flow graph. It shows the execution sequence of the program. This graph represents how control moves from end to end. Next, CFG represents how value flow through the variables. It shows the dependency of the data between the statements. Next, CPG section. It combines AST, CFG and DFG into the single graph. This provides a complete view of the program and it is useful for the advanced code analysis and security applications. Next, it is automata theory in lexical analysis. This section demonstrates the connection between automata theory and the lexical analysis. Finite automata are used to recognize valid tokens during the lexical analysis. Next, AI code assistants and the structural representation. Modern AI assistants like ChatGPT, GitHub, Copilot and Gemini understand code through the structural representation. It enables AI system to provide accurate code explanations and suggestions. And here is the applications and the conclusion. Thank you.